Welcome to the channel. Today in this tutorial, let's see how recursive Fibonacci Python program works. Here we have our program. This is function definition. Execution begins from here. First, take the input from the user. Let's take 3 and value is 3. Then Python will execute this statement. Here you can see a function call. So when a function is called, a stack frame is created and that stack frame is added to the call stack. Here this is our call stack. For understanding purpose, I'll write like this. But actually every stack frame contains return address, local variables, parameters and all. Next Python will execute this function body. Here n value is 3. N is equal to 0? No. N is equal to 1? No. So Python will execute this. Return Fibonacci of n minus 1 plus Fibonacci of n minus 2. That is actually, I'll write fib short form. Here we can see two function calls. First it will execute this function call. This is a function call. So new stack frame is created and added to stack. Python will pause the execution of this function and it will execute Fibonacci of 2. So n value is 2 here. N is equal to 0? No. N is equal to 1? No. Return Fibonacci of n minus 1 plus Fibonacci of n minus 2. That is actually, here you can see two function calls. First Python will execute this function call. For this function call, new stack frame is created and added to the call stack. Now Python will pause the execution of this and it will execute Fibonacci of, here now n value is 1. N is equal to 0? No. N is equal to 1? Yes, it is true. N is 1 here. So it will return 1. This function returns the value and ends the execution. So when base case is satisfied, function returns the value and this stack frame is removed from the call stack. This will return 1 to its caller, to here. Now Python wants to perform addition operation, but it doesn't know the value of this. So this is a function call. So another stack frame is created, Fibonacci of 0. Now Python pauses the execution of this and will call Fibonacci of 0. So here n value is 0 now. If n is equal to 0, true. Base case is satisfied here. So when base case is satisfied, function returns the value and that is the end of that function. So here this stack frame is removed from the call stack. So this will return 0. It will return the result to its caller. So it is called here. So here 1 plus 0. Now this function resumes the execution and it will perform addition. 1 plus 0, it will return 1. So this function will returns value 1 and stops the execution. So factorial of 2, this stack frame is removed from the call stack. So here we got the answer for this. Now Python will resume the execution of this. To perform addition, here we can see another function call. Python pauses the execution of this and it will execute. It is a function call. New stack frame is added to call stack. Next Python will execute this function body for n value 1. If n equal to 0, no. If n equal to 1, yes, return 1. So this function returns 1 and stops the execution. So when it stops the execution, this stack frame is removed from the call stack and it will return the result to its caller. It will return 1. Now this function Fibonacci of 3 will resume the execution. 1 plus 1, so it will add that and it will return the result. Return 1 plus 1. So we'll get 2. So this function will return 2 now. After completing the execution of this stack frame is removed from the call stack. 2 will return to here because this function is called here. Then it will print the result. So we'll get the output as 2. That is the Fibonacci of 3. We can actually represent it like this. In the call stack, if you observed clearly, here when we call Fibonacci of 3, maximum stack frames at a time is 3 stack frames. If we call Fibonacci of n, then we need n stack frames. That's why space complexity is big O of n. Okay, so this is about Fibonacci problem. That's it for now guys. Thank you for watching. Don't forget to subscribe to my channel. I'll meet you in next class. Till then, take care.